Welcome back, dear students, to the tetrahedron chemistry classes. In today's class, I am going to discuss very important numericals based on the mass absorption coefficient, which we generally use in the X-ray crystallography, right? And the formula for and the symbol for mass absorption coefficient, or you can say the mass extinction coefficient, is mu over rho, and sometimes it is also written as mu with subscript m, right? So what is this actually? First of all, we need to check the background of this particular mass absorption coefficient, and after that I'll solve the numerical for you. Okay, so what is mass absorption coefficient? Mu by rho. Basically the unit of mu by rho is in centimeter square per gram, right? And it is a very standard way to describe the X-ray absorption strength of any material, right? Whether the material is the pure or the mixed. That means if you pass the X-ray through the material, then how strongly the material will absorb the X-ray. This will be given by the mass absorption coefficient or the mass extinction coefficient, right? So alternatively, what we can say, the mass absorption coefficient tells us how strongly a material absorbs X-rays per gram of its weight. This is very, very important. Per gram of its weight. This we will use in solving the numericals based on mass absorption coefficient, right? And in the formula where mu is the linear absorption coefficient and the unit of this linear absorption coefficient is centimeter inverse, right? And what is this? This is how much X-ray beam weakens while traveling 1 centimeter inside the materials. Rho is the density of the material, which is of course in the gram per centimeter cube, where rho is the density of the material, and thus mu by rho is the absorption per gram, right? Because it is per gram, it is independent of how tightly the material is packed. That means there is no importance of packing of the material, whether it is perfectly packed or not. And this makes this mass absorption coefficient a very versatile method for the mixtures, alloys, solutions, powders, or biological samples. Any kind of samples you are having, you can determine the mass absorption coefficient of the material in any form. So this is the basic background of the mass absorption coefficient. Now we will solve the numerical based on this. So this is your first numerical. A sample of an alloy, as I already told you, it will be applicable for any kind of the substance. A sample of an alloy has mass absorption coefficient of 4.75 centimeter square per gram for the line of the copper at 1.5 angstrom. This is the wavelength of the light, right? And this is the copper line which generally we use in the X-ray machines, right? What will be the mass absorption coefficient for the zinc line at 1.43 angstrom? That means you have been given this mass absorption coefficient of 4.75 centimeter square per gram for the line of the copper at this particular wavelength, and you have to calculate the mass absorption coefficient mu by rho, or simply the mu m, for the zinc at this particular wavelength, that is 1.43. So how we can approach this particular numerical, you can see here, and this is very, very important for the various examinations, right? So first of all, you need to know what is the formula. So formula, as you know, this is basically your mu m, and this mu m is written by mu over rho, and mu over rho is equals to k multiplied by cube of the wavelength, where k is the extinction coefficient, right? It is extinction coefficient, and lambda is the wavelength of the light. So this is the formula. So you are having the two different wavelengths, so you can convert this formula into the two different formulas and then take the ratio to solve the particular problem. So what is given in the question? So it is given in the question, which is your, say, mu by rho, and I'm calling it as for the first element, that is equals to 4.75 centimeter square per gram, right? And this is given, and this is given for the copper line. For copper line at lambda 1 equals to which is your 1.5 angstrom, and then you need to calculate mu over rho for the second element which is present in the alloy. This you need to calculate, right? So for this, what we can do, we can make two different equations. So first equation is here and mu by rho, we have formulated two different equations for this one. We can set the proportion. So here I am writing setting the proportion, or you can divide 2 by 1 as well. This will not make any difference. Okay. So what we will get now, we will get mu over rho for the first one divided by mu over rho for the second one, because we are dividing equation 1 by equation 2. Extension coefficient lambda 1 cube divided by extension coefficient lambda 2 cube. So your extension coefficient kk will cancel out from here. For the first one, this value is given, which is your 4.75. I go back. This is given as 4.75 centimeter square per gram, and lambda is 1.5 angstrom. So how we can solve this? This I can write as 4.75 centimeter square per gram, here mu by rho for the zinc, which you need to calculate. So instead of writing 1 and 2, you can write here copper and zinc as well. Okay. So this will not make any difference. This is the only, this is the way of solving the problem. Not the only way, but the way of solving the problem. Okay. For copper, the wavelength is given 1.5, and for the copper, this wavelength is given 1.43, and you need to take the cube of this one, right? And then you can solve this particular expression. So this will, if you solve this one, so this will give you, then this will give you 4 times 3 times, right? This will give you 4.11 centimeter square per gram. So I have skipped few of the mathematical steps here. Okay. And for this you need to know the how to solve the different kind of the equation. So what I did actually, I take the reciprocal of this one, 4.75 centimeter square in the denominator, and then this will also reverse, and after solving this you will get this particular value. So let us check. 0.75 divided by 1.154, which is equals to, yes, 4.11. It is quite fine. This is 4.11. So here 4.11 centimeter square per gram is the mass absorption coefficient for the zinc in the particular alloy. Now this is your second problem. An amount of the cobalt in a particular sample in X-ray spectroscopy gave the following readings for the calibration curves, as concentration is 0.5, then reading is 17, and when concentration increased to 1, it is 23, and when it is 2, it is increased as 34, and when it is 2.5, it is 42. So it's actually increasing, right? When you increase the concentration, then the reading is also increasing in the calibration curve. With the help of this, you can make your calibration curve as well, but I am not going to make the calibration curve here. I'm only solving this particular problem, right? If a known sample has a reading of 22, what is the percentage of cobalt in the sample? So whatever the sample you are having, it is the sample of the alloy, and you have been given the data only for the cobalt, right? And its reading by which you can calculate you can make the calibration curve, right? And you need to know what is the percentage of the cobalt. So I am going to solve this particular problem. So how we can solve? See, what we will do, we will assume the linear relationship between the concentration of the and the reading. So we are assuming that there is a linear relation, right? And whenever the linear relation is there, you can always apply your straight line equation, y is equals to mx plus c, and then you can calculate the m, right? And with the help of the m, then you can go for the concentration of the cobalt in the unknown sample at this particular reading, right? So it is very, very important. We are assuming the relationship between the concentration and the reading as the linear relationship, right? And we will calculate the m, which is your slope, right? In the calibration curve, this m, say, is the slope. So slope can be calculated with the help of the readings divided by concentration. Okay. And say, for example, I am using this 42 last point and the initial point, 42 and 17. You know what is the slope? Now it is very, very important to understand whether the slope is the rise by run, right? in any your straight line equation. Linear relationship is there, and of course this will be divided by, for the 42 the concentration is 2.5, so we will write the 2.5 here, and for the 17 the concentration is 0.5, so we will write minus 0.5 here. That will give you 25 by 2, that is 12.5, right? This is the slope of the line. And now you are having this equation y equals to, where m we have calculated, right? M we have calculated. So we can change this equation. Instead of y, we can write the reading in the straight line equation. That is equals to your m and multiplied by the concentration, just like that. So what you are having? See, you are having your reading, you are having your slope, you are having your concentration, then you can calculate this constant C, right? This value, this C. So how we can calculate this C? For this, first of all, we will calculate for the this value 17, right? Where 0.5 concentration is there and 17 is there. If you solve this, then you will get, instead of reading, you are having this 17. You are assuming the linear relationship between the concentration and the reading, please remember. And you have calculated your M 12.5 here, and you are putting this, M is here, and then concentration at 17 is 0.5, 0.5 here, and then plus B. So how we'll calculate the B? The next, here B will be equal to simply 17. If I go back 17 minus 6.25, yes. So if you multiply these two, right, this will give you, see, this is just half of this. This 12.5, when we multiply it with the 1 by 2 or the 0.5, so this will be your 6.25, okay, minus 6.25. And again, I made a mistake, because in my notes, I have written this as B. That's why I am always taking this as B, but it is C actually. And the value of the C you have calculated is 10.75 now, right? This is the value. So therefore the equation 1 can be rewritten as, right? So your equation 1, where was the equation 1? If I go back, right, this equation is the equation number 1, and this can be rewritten as, so I'm writing your reading equals to 12.5 multiplied by the concentration plus your value of C, which is your 10.75. For this, now you need to calculate for, I go back, 22, right? Reading at 22. So now your reading is 22, which is in the question. 12.5 you have already calculated, which is your this slope. You will multiply this with the concentration, because you need to calculate this one, and plus 10.75 you have calculated. So I have calculated your 10.5, this value of the C, right? So made a mistake here. This is basically your C. So now I'm having everything. I'm having this C, I'm having this M, right? And I'm having the reading, which is 22. So I can easily calculate the concentration of the cobalt. If you solve this particular equation, what you will get here, concentration of cobalt in the unknown sample equals to 22 minus 10.75. We'll transpose the equation, and this 10.75 will go on the left hand side, so it will change its sign, divided by 12.5, and this will give you minus 10, that will give you 11.25, right? 11.25 over 12.5. If you solve this, this is 0.9, roughly 0.9%. So this is the percentage of the cobalt in the unknown sample. Okay, so let us check it again. So what I can do, I can write 11.25 divided by 12.5. Yeah, right. This is the answer actually. So here, evaluate the mass absorption coefficient at 0.436 nanometer of the sample. Of sample containing 85% iron, 3% nickel, 9% copper, and 1% zinc. So again, it is an alloy, and this alloy is having the iron, nickel, copper, and zinc. If the corresponding mass absorption coefficient for the pure metal is 0.436 nanometer, are respectively 610 for iron, 715 for nickel, 760 for copper, 910 for zinc, all in the centimeter square per gram. So if you have the n number of the species, so you can calculate what? This mu by rho for the n species. and n species is nothing but the sum of all the individual constituent present in the alloy. So the formula which you will take, what, nu by rho, and you are having different metals, say iron you are having. So say your first is iron, and then you will multiply this with the weight, and then plus your second one. The mass absorption coefficient of an alloy is the weighted average of the pure metals, right? And you have been given various things. So what we can do, we can first of all, for iron, percentage is 85%, okay, and mu by rho for this iron is 610 centimeter squares per gram, centimeter squares per gram, okay. And then after iron, you are having, so for nickel, the percentage of copper is 9. For the percentage of the zinc is 1% only. At different percentages, you are having the different values of this. Okay, mu by rho and the entire sample. So I'm writing sample here. So this will calculate for, first of all, we will calculate for the iron. Here you see, iron is 85%, mu is 610. So 85% is basically 85 by 100. We can write this as a fraction, this 85% as a fraction. So this value 610 multiplied by 85 over 100, because it is weighted average, right? This you need to add with your second element, nickel. Third is, this is what here, 760, your zinc, and for zinc it is given. And if you quickly solve this one, so this will give you your 610 multiplied by 0.85 plus 715 multiplied by 0.03. This will give you 518.5 plus 21.45 plus 68.4 plus 9.1. Right? If you add all together, this will give you 617.45 centimeter square per gram. A mixture contains the chloride of the copper and calcium at 0.193 nanometer, right? What will be the mass absorption coefficient if percentage of calcium is 60 and the copper is 40? The mass absorption coefficient for calcium is 306 and for chloride is 198, and for copper is 92.6 centimeter square per gram at the particular wavelength. So this problem actually is quite a lengthy problem. Mu by rho for calcium, it is given 306, and mu by rho for copper 92.6 centimeter square per gram. Please remember, okay. And for chloride, it is also given centimeter square per gram. So this thing is given in the question, and basically your composition is what? I'm writing composition 60% of calcium plus, basically. See, now it is very, very important. Since it is a mixture, right, of the chlorides. So what we can do, we can calculate the mu by rho for the mixtures, right? And for this, we need mass fraction of each component. So how we can calculate the mass fractions? Mass fraction of calcium, Ca2 positive. So this is nothing but mass of calcium divided by mass of calcium chloride, because you are having the chlorides of the calcium and the copper. You know, calcium is what? 40.08. Calcium chloride is 110.98. If you solve this, the value will be 0.361. Similarly, you can calculate for the chloride. The weight of the chloride, you know, just 35.5. The formula will be your CaCl2, right, or CuCl2. So 2 will be multiplied with the weight of the chloride divided by 110.98. Right? It is in the calcium chloride, right? For one equivalent of the calcium, you need the two equivalents of the chlorine. And this will give you 0.639. And then calculate for the copper. Mass fraction of copper, and the weight of the copper is 63.55. It is the atomic weight. And your CuCl2 134.45. This will give you 0.473 mass fraction of chloride as well from here, which is nothing but 35.5 multiplied by 2 divided by this value of 134.45, and this will give you 0.527. So these you have calculated. Okay, now you can calculate the mass absorption coefficient per weight. Okay, so first of all we will calculate the calcium, and then for the chloride, and then the calcium chloride, and then for we'll go for the copper, and then the chloride, and then for the CuCl2. Okay, and then you will get your answer. Mu by rho, and I'm calculating for calcium. This would be nothing but extinction mass absorption coefficient of calcium will be multiplied by mass fraction of calcium, mass of calcium, and for the you will use this formula. So this value is given 306, mass fraction you have calculated 0.361, and mass of the calcium is given in the question. 60% is there. It was 60%. It is 60%, and copper is 40%. Okay, so if you solve this, this will give you 66.3 centimeter square per gram, and then you can calculate for the mu by rho or Cl, and it is mass absorption coefficient is given as 198. We'll use the same formula, and 0.639 you have calculated in the last slide. Yes, this one, and it is multiplied by 0.6, and then this was your actually 60%. So 60% can be written as 60 by 100. That will give you 0.6. That's why it is there. Okay, and the value will be 75.9 centimeter square per gram. Okay, and then here mu by rho 66.3, which you have calculated here, plus for chloride 75.9, and this will give you 142.2 centimeter square per gram. Okay, and then you can calculate for the CuCl2. Sorry, you can calculate for this CuCl2. So I'm giving you the answer only. Mu by rho, similarly I'm writing similarly here, similarly centimeter square per gram. So this will be the answer actually.